Hello, I am Mallikarjun and my teammate is Shraddha, and we are here to present our project, which focuses on building a retrieval augmented generation system. Our project is about building a mental health chatbot, which we call MindMate. Basically, it's like a mate who responds with reliable and context-aware information for the mental health queries that one asks. Our main objective of the project is to develop a RAG-based system using three different LLMs and evaluate these models and compare the responses and performance generated by these models, ensuring the models adhere to the ethical and critical guidelines provided. Coming to the statement of our project value, we believe our project MindMate provides important values. It offers a private, affordable space for users to explore mental health concerns. It also provides on-demand support and helps users access when professional help might be needed. Before building our project, we have reviewed few of the state-of-the-art techniques that are already available online. So we have referred to the Soulmate, which adopts large language models for mental health support using RAG techniques, risk detection, and proactive guidance as well. Also, one of the papers which really drived us to finish our project is LLM Therapist, which is a multimodal RAG-based system acting as a behavioral healthcare assistant. On overall, these both the papers inspired our focus on combining retrieval and model personalization. And the approach that we followed is by using three different LLMs, which is Mistral 7B Instruct, Llama 27B, and Pi 3 Mini. All of these are quantized models since we are running this locally on our CPUs with 32 GB RAM. We built this entire chatbot on Streamlit platform, which provides us interactive experience as well. And also we have built our knowledge base from three published sources on psychology and trauma. Coming to the system architecture, firstly, our system starts by loading the PDF files, extracting their text. Then we split the text into chunks, and then these chunks are converted into embeddings using a sentence transformer. And these embeddings are stored in FAISS vector store, which helps in fast retrieval. So when a user asks a question, we fetch the relevant chunks from the database, then pass them along with the question to our LLMs. And then these LLMs generate the context-aware answers, which we then evaluate using various metrics, which on which few of our evaluation metrics are perplexity, hallucination rate, polarity, and subjectivity. We evaluated these models based on all of these evaluation metrics because they provide fluency and predictability by perplexity. And hallucination rate is to quantify made up information present online versus the context that we have provided. And polarity subjectivity is to assess the tone and neutrality of the model responses. On overall, these metrics helped us systematically compare all the model performances and make a graph so that which model is performing well. Coming to our deliverables include building a chatbot, which is a MindMate, and then batch run the evaluation of all the LLMs on domain-specific questions, and storing the responses evaluation metrics in the form of a CSV file, which later can be analyzed for the performance evaluation. Our deliverables also include creating a detailed report entailing the process and findings. Now let's go into the code demo. Firstly, we have built this project with the different Python scripts, which is build vector store, LLM evaluation, and mindmate.py. So coming to the build vectors store. Basically, this file which we use to generate the FAIS as a vector store. Here is the dataset that we are using. Basically, it loads the PDF files, then chunks into small overlapping documents. Then after it embeds the chunks using a sentence transformer. In our case, we are using the mini LM uh, for the embeddings. Then after it stores in the form of FAISS vector store, which can later be used for the retrieval mechanisms. Then after we have already run this code and successfully generated the FAISS vector store here, which is stored in the vector store. Then after the second file is LLM evaluation. Basically, we have scripted this file in a way that it only runs on 10 questions with 3 different models, so that the models that we are including here will run all the 10 questions and provide the responses, including the evaluation metrics. And all of these will be stored in a CSV file here. Then later we can analyze the CSV files. So basically, we are loading the models through Hugging Face. So we have already ran this Python file before. So we have downloaded all 3 models from the Hugging Face repositories and stored it locally. And the locally stored models are then loaded using Llama CPP, which is a great library to run locally stored LLMs on CPUs. So this is for the 10 domain specific questions and answers evaluation. Then comes the mindmate.py. We have created this a Python file to create our web app, basically a MindMate chatbot, which is deployed in the Streamlit platform. A user can typically type a mental health related question, then can select one or multiple models from the sidebar. We have already ran this file as well, and it's hosted here. So we can go here and check out the web interface. So this is the locally hosted web interface through Streamlit platform. This is a real-time chatbot. We can check or uncheck the models that we are needed and ask the question here. So let's go and ask, what is mental health? Then we can click on ask. So the entire process will go on here and gives the answer here. It takes a little bit time because we are running it on the CPU. So it's loading Mistral right now. Basically, this app retrieves content from FAI's database, then it sends the context plus question into the selected LLMs. In our case, we have selected Mistral, Llama, and Phi 3 Mini. So it's asking all 3 of the models for a response. Then after it completes the retrieval process, it calculates the evaluation metrics and it displays here itself. And users can also go through the source content as well. So here it have responded with the Mistral with the evaluation metrics, and here is the source content. Similarly, it will load for the other 2 LLMs as well. Um, since we are running it on the CPU, we we are using the top one document in the retrieval mechanism. So the model is little bit hallucinating because of this, since we don't have the GPU computation resources. But we have tried it in the Colab GPU with a limited access, and it worked great over there, and the hallucination decreased. And we have generated all this data using the Google Colab GPU by searching for the top 10 retrieval documents. So this are done and it's given the evaluation metrics. So we have uh, simulated the evaluation summary into the visualizing graph, and we found that 5 3 mini continued to show the latest lowest hallucination rate, maintaining the strong grounding in the retrieval information. And the Mistral 7B achieved the lowest perplexity, indicating it generated the most fluent and coherent responses. Across all the models, the sentiment remained mostly neutral and objective, which is critical for adhering sensitive mental health topics appropriately. And for our references, we mainly cited the Soulmate paper, which is published in the IEEE Global Communication Conference. And these both the papers provided a strong foundation for adapting RAG in the mental health domain. Thank you for listening to our presentation. We'll soon share our project code findings and results on the GitHub platform.